Question number 56. 1 mole of a monatomic ideal gas perform the following reversible operation as shown in the diagram. So we have a S versus T graph. We have to select the correct statement about the process. So in the first statement, the examiner says during A to B, the pressure of the gas increase. So if you look at the graph, the value of S remains constant from A to B, and it is a reversible process since we are able to draw the plot of S versus T. So we can say that the process A to B is adiabatic. So if the process A to B is adiabatic, we can use the equation for state. So we have PV ki power gamma equal to constant. So this can also be rearranged to give us T ki power gamma upon P to the power gamma minus 1 equal to constant. Now from the graph we can see that temperature is increasing, and if we use this condition we can clearly see that the pressure must also increase in the system. So from A to B, as T increases, the value of pressure also increases. So the first statement is correct. If you look at the second statement now, during A to C, delta S of gas is 0. So if we look at the path from A to C, so A to C, the value of delta S is negative as SA is more than SC. So SA is more than SC. So delta S from A to C shall be negative. So the second statement is incorrect. A to B is adiabatic expansion. So students, if we talk about A to B, so the path A to B is an adiabatic process. We had already seen that before. But if we talk about the expansion or compression part, we can have PV to the power gamma equal to constant. Or we could also have TV to the power gamma minus 1 equal to constant. Now we can see that as temperature increases, the value of volume should decrease for the product to be a constant. So we can see that VB will be less than VA. So the path A to B is not adiabatic expansion, but it is adiabatic compression. So the third statement is also incorrect. If you look at the fourth option now, delta S is positive for A to C process via A to B and B to C. So we had already seen that the delta S for A to C is negative. So the fourth statement is also incorrect. So for this question, the examiner seems to be interested in the correct statement, and we have to mark option 1 as the correct answer to our question. Let us look at the next question. Question number 57. Brine can be used to extract chlorine. Consider the following statements for this process. So the examiner seems to be interested in knowing about the delta G0 and the E0 values for this reaction. Now students, we know that the extraction of chlorine from brine includes electrolysis. And in electrolysis, we use an external source to make the non-spontaneous reaction spontaneous. So the delta G for the overall reaction would have been positive, hence we had to use electricity for this reaction. So delta G0 shall be positive, which follows that E0 should be negative. So looking at the options, we can see that S1 and S3 are correct, and we have to mark option 3 as the correct answer to this question. Question number 58. Which of the following is not correctly matched? So in the first option, malachite. Malachite is CuCO3 dot CuOH whole twice. So it is basic cupric carbonate and it is an ore containing carbonate ions. So the first match is correct. If you look at the second statement, iron pyrites is a sulfide ore of iron. This is also correct, students. Iron pyrites is given by FeS2, which is indeed a sulfide ore of iron. So second statement is also correct. If you look at the third statement now, Van Arkel method is used for the purification of titanium. This statement is also correct. And if you look at the fourth option now, magnesite is not an oxide ore. Magnesite is MgCO3. It is a carbonate ore of magnesium. Okay. So students, we have to select option 4 as the correct answer to this question. Let us look at the next question. Question number 59. The correct order of ionic radii of Tb3 plus, La3 plus, Eu3 plus and Lu3 plus is. Students, the examiner seems to be interested in knowing about the ionic radii of the lanthanides. So we know that the ionic radii smoothly decreases. as the atomic number increases. And now if we look at the atomic number of the species which are given to us, so we have lanthanum, we have europium, we have tiberium, and we have lutetium. So if we talk about the atomic numbers, lanthanum has an atomic number of 57, europium has an atomic number of 63, tiberium has an atomic number of 65, and lutetium has an atomic number of 71. As we move from lanthanum to lutetium, the ionic size should decrease, which is given correctly in the option 3. So we have to mark option 3 as the correct answer to this question. Let us look at the last question for this test. Which of the following is correct statement about these given structures? So we have been given orthoxylene, metaxylene, and paraxylene, and we have to talk about the thermodynamic stability of these three structures. So we have been given CH3 groups attached to benzene, and these CH3 groups exert a plus H effect. Now, since we have two CH3 groups, we have to distinguish between the effects of both of these groups. So we can probably label them. We can label one with the green color in each of them, and we can label the other with, let's say, red color. Now we can talk about the plus H effect exerted by these groups. We'll start with the red ones. The plus H effect is felt at the ortho and the para position. So this red CH3 will create delta negative at these positions. In the first structure, in the second structure at these positions, and in the third structure at these positions. Okay. Now we can also have the effect of the other CH3 group, which is in green color. So we'll have the delta negative at the ortho and the para again. In the second structure, we'll have the effects consolidating. The charges will appear at the common positions. In the third structure again, we'll have delta negative at different positions. If we look at all of these structures very carefully, we can see that the red CH3 creates a delta negative at the position where the green CH3 is present in the first structure as well as the third structure, and vice versa. It is only the second structure in which none of these two labeled methyl groups create a delta negative at the position where the other CH3 is present. So this will be more stable than the others. So students, if we look at the options, we can clearly see that the correct statement is given in option 1, which says that 2 is the thermodynamically most stable among these three structures which are given to us. So students, we have to mark option 1 as the correct answer to this question. So this is it for today, guys. I hope the solutions were clear to you. Thank you.